Hi guys, welcome to my channel, and today we're going to talk about round robin scheduling along with the examples later on. At the end of this video, I hope this will help you understand the basic concepts of round robin scheduling. Let's get started. First off, what is round robin scheduling? A round robin is one of the algorithms employed by process and network schedulers in computing. Time slices are assigned to each process in equal portions and in circular order, handling all processes without priority. So next is, what is time quantum? In round robin, the time quantum is fixed and then processes are scheduled such as that no process gets CPU time more than one time quantum in one go. So in this demo, let's consider the following set of processes that arrive at time 0. And with the length of the CPU burst given in milliseconds, the time quantum taken as 4 milliseconds for round robin. So for the process P1, P2, and P3, we're going to set the arriving time at 0 and time quantum at 4 milliseconds. Alright? So for our first process, P1 will get the CPU at 0 milliseconds. So P1 will have to execute 24 milliseconds. Why 24? Because our burst time for P1 is set as 24 milliseconds. The question is, will it be allowed to execute for 24 milliseconds? Given our time quantum is only 4 milliseconds, the answer there is no, because this is a round robin scheduling and we have a time quantum and it only be allowed to execute for that particular period of time, which is 4 milliseconds. So P1 will only execute 4 milliseconds and it will be from 0 millisecond to 4 milliseconds. So this is the formula. 0 plus 4 would be 4, right? And then what happened to P1 is that 24 minus 4 is equals to 20, and 20 will now be the new burst time of P1. After that, P1 will preempted and the CPU will be given to the next process in the queue, which is P2. In this case, the burst time of P2 only have 3 milliseconds as given here, which is less than the time quantum, meaning it will only execute for 3 milliseconds. So for 4, so 4 plus 3 equals 7. So our given here will be 7. And P2 will voluntarily release the CPU because its burst time is only 3 milliseconds, which is less than the time quantum. Again, our given time quantum is 4, but the burst time of P2 is 3. So what will happen is that P2 will voluntarily release the CPU because the process is already done. So in this case, we don't have to preempted P2 because the process is already completed. Our next process would be P3. As you can see, P3 has the same burst time with P2. So what will happen is that from 7, we will now add the burst time of P3, which is 7 plus 3 would be 10. So 7 will become 10 in here. Next is, since we are done with P2 and P3 and we preempted the P1 a while ago, we will now proceed to P1 again. In this case, since P1 did not complete its execution in the first quantum, the CPU will again be given to P1 and it will be allowed to execute for one quantum of time, which is 4 milliseconds, and it will go like that until it reaches the end of the queue. So what will happen is that 10 plus 4 equals 14. So 14, right? And then we're going to compute our new burst time for P1, which is 16 minus 4 is 12 here. Okay? And we're going to repeat to complete the process. And we'll continue that process until P1 completes the process. So again, 14 plus 4 is 18. And it'll be here. So we're going to compute again the new burst time of P1, which is 12 minus 4 is 8. Okay, since it's not yet completed, we're going to place P1 again in the process. So from 18 plus 4 is 22. So 22 will be here. Our new burst time will be 4 because 8 minus 4 would be 4. We're going to put P1 in here. So from 22 plus 4, it will be 26. And our new burst time would be 4 minus 4, 0. And P1, our completed process would be 30. So just to check if we're on the right track, we'll just need to add the burst time of the three processes, which is 24, 3, and 3. That would be 30. So just to check we're correct. So in this slide, I'm going to show you two methods on how to compute turnaround time and waiting time. So for us to compute the turnaround time, we need to subtract the completion time with the arrival time. So for P1, 30 minus 0 is equals to 30. So 30, we got this 30 from here because P1 completed the process with the 30 milliseconds. And of course, our arrival time is 0. That is why it is 30 minus 0. And the answer here is 30. Same with P2 and P3. So for P2, the completion time is 7 because it completed in here. And in P3, the completion time is 10 because the task or the process was completed with the 10 milliseconds. So since we have the turnaround time here, we just need to subtract it with the burst time. So for P1, 30 minus 24, since our burst time for P1 is 24, so that would be 6. And then P2, the answer is 4, and P3, 7. So this second method, it looks complicated, but it's really not. So what if you just need to compute the waiting time and not the turnaround time? So that is why we have this second method, which only compute the waiting time, and you don't need to compute the turnaround time. So for us to compute the waiting time, here is the formula, right? So for P1, 26 minus 0 minus 5 times 4 is equals to 6. So where did we get the 26 of the last start time of P1? So as you can see, here's the completion time of P1, but the last start time of P1 is 26. So 26 minus arrival time. Again, our arrival time was set to 0. Preemption is set to 5 because P1 was repeated 5 times before it was completed. So 1, 2, 3, 4, 5. Right? And time quantum, again, is set to 4 milliseconds. So the answer for P1 in waiting time is 6. So for P2, it is 4, and P3 is 7. So for our next slide, we're going to compute the average turnaround time and average waiting time. So for first method, what we have here is that we need to add all the completion time of the processes and then divided by into 3. Why 3? Because we only have 3 processes, which is P1, P2, and P3. When adding these 3, it is 47 divided by 3, and that is 15.66 milliseconds. For average waiting time, we just need to add again the 3 processes and divided by into 3, and that would be 5.6 milliseconds. Same with method 2 on how we compute the waiting time. Add the 3 processes and divide into 3, and same answer, 5.66 milliseconds. Thanks for listening, and please subscribe to my YouTube channel for more videos. Bye!